Hello and welcome to Equity Education, the chemistry version, and today we're going to have a very quick video based on identifying aldehydes and ketones. Okay, so we'll get started. So let you open up your booklets. So it is possible to distinguish between aldehydes and ketones with other carbonyl containing compounds such as esters, and I haven't left enough space, carboxylic. Let's just add a bit of room in here. Carboxylic acids, and we do this by adding something called 2,4-DNPH. Okay, so you don't have to remember the whole name. You might see it as 2,4-DNP as well. If you did want the whole name, we would call this 2,4-dinitro phenyl hydrazine. But 2,4-DNPH is fine. So this is the thing we add. Okay, so if an aldehyde or a ketone is present, an orange or yellow precipitate will form. Okay, this PPT means precipitate. So remember, a precipitate is a solid suspended in a solution. Okay, so you can't see through it if it's in a test tube. Okay, it may also look a bit red, so it could be an orange, a yellow, or a red precipitate, but the main point is that we get this precipitate form. Okay, so it is possible to identify the specific aldehyde and ketone present because each precipitate that we formed, each precipitate compound that forms has a specific melting point. Okay, so once we've added this 2,4-DNPH to my aldehyde or ketone, it will react together to form a precipitate. And these precipitates will all have specific melting points dependent on what the aldehyde and ketone is at the beginning. So if we wanted to identify the specific aldehyde, for example, if it was ethanol compared to butanol, we could identify this by these following steps. So first of all, add 2,4-DNPH and a precipitate will form. An orange, a yellow, or maybe a red precipitate will form. We can then filter and recrystallize the precipitate. Okay, so this purifies the precipitate, and then we can measure the melting point and look up this melting point in a data booklet, and it will give us the name of the aldehyde or ketone. Okay, so this method can identify a specific aldehyde or ketone. However, if we wanted to identify between the just an aldehyde and a ketone, we could do the following experiments or qualitative tests. So aldehydes oxidize to carboxylic acids. Ketones are resistant to oxidation. So there are two oxidizing mixtures that can give us observable results. One is my H plus and dichromate ion, such as, and the solution in the oxidizing mixture might be potassium dichromate, acidified potassium dichromate. The conditions, we need to warm it. Okay, and the results, if an aldehyde is present, we will see a colour change from orange to green. Exactly the same as our oxidizing mixture we use to oxidize primary and secondary alcohols. So we will see this colour change. So if an aldehyde is present, there'll be a colour change of solution. To be a bit more specific, of orange to green. And just as a point of reference, the reason why this happens is because we're changing the oxidation state of our chromate here, our chromium transition metal here. I won't go into too much detail about this because we don't know, but what actually occurs is this reaction. So our Cl3 plus is green and our Cl2O7 2- is orange. Okay. Our second qualitative test that we can carry out is by adding Tollens reagent. Again, we just need to warm, and our result, if an aldehyde is present, a silver mirror will form. So these are usually, both these tests are usually done in test tubes. And when we say a silver mirror, what actually happens is, I probably should just repeat this, so just tell you what this is. So Tollens reagent is a mixture of AgNH3 So this is my Tollens reagent. And what actually happens is that the Ag plus, which is a solution, is reduced to silver. So this is my silver mirror. And as I was saying, it's usually done in a test tube, and it's the silver mirror. So on the outside, in the inside of the test tube, there will be silver coating the inside of the test tube, which looks like a silver mirror. That's why we call it the silver mirror test, or adding Tollens reagent produces the silver mirror. Just on a side point is that what actually happens to the aldehyde here is, I'll just do it down here because there's enough room, is we get oxidation. So the aldehyde is oxidized to our carboxylic acid. So this is oxidized, whereas the silver ion is reduced to solid silver to produce the silver mirror. Okay, right, so very quick, as I promised, and that's it for now. I hope it was useful, and I will see you next time. Okay, bye bye.